Okay, you remember that whole big thing we did yesterday? Now I want to see if you can do it yourselves. You can do it. The guy just gave you the whole speech about Steve Jobs and you can do it and blah, blah, blah. You can't even do this. I even told you how to do it. Let's go. Coding matrix, message matrix. I want you to show me how you would code and then decode. I'll start you off. Start writing. What are we going to do? How are we going to code? The coding is the easiest part. How do you code it? What times what? This times this, right? C times M. What number is H? 8. E. L. 14.
No, sorry.
A, B, C, D, E, F, G, H, I, J, K, L. Isn't it 13?
Oh, no, sorry.
F, G, H, I, J, K, L. It's 12. What is P? L, M, N, O, P. 16 or 15?
Is that O?
I'm going to trust you people. M? E? Okay, so you guys are telling me that it's 8, 5, 12, 16, 13, 5. Can you guys double check that? That's important. Who agrees with that for the changing of the letters? Because I don't want to go on unless we get that done. You guys are going to make me write this, aren't you?
Yeah, that's right.
Yeah.
Okay, who says yes? 1. Anybody else? 2. Anybody else? Kim, you signed off on that?
Yeah.
Sheba, you're signing off? Okay, good enough. So, Sheba, you want to give me that number? 8 plus negative 12 gives you what? Negative 4, and a 0 gives you a negative 4, right? We can go this way or this way, it doesn't matter. Let's go that way. I think I made you guys, when I first showed you, did I show you going to the right? Okay, so we got a 5 and a 16, which gives us a minus 11 and a 0. Okay. Now what do we got here? We got a 0 and, nope, we got an 8 and, which just gives us a 32 and a 13, 42, 45. I hope you guys are double checking this. 5 and a 32 is a 37 and a 5 is a 42. Sam, you're double checking? Good. We have a 0, 20, no, I apologize. 0, a 12, and a 13 is a
25.
Good. Sheba, keep going.
0. You can't see 16.
So 1 and a 1.
So
21.
Beautiful. Okay, so that's part 1, right? Do you guys agree with that? Okay, moving on. Now you got to do a little bit of the logic. You say, we have to remember that the whole thing behind this is we just did that, right? But when I taught you guys this way back, I said, well, B, C, D, E, F, G, H, I, right? That's going to represent that matrix times the coding matrix. What was our coding matrix? Right there, right? 1, 1, 0, minus 1, 2, 1, 0, 1, 1. Now what is... I'm doing it over here. A, B, C, D, E, F, G, H, I. Coding matrix. You want to call it down. 1, 1, 0. Column. Next one.
-1, 2, 1.
Next.
0, 1, 1.
Now, if that's C inverse and that's C, you multiply them, what should you get, Joanna?
I.
1's down the middle, right?
Right.
With 0's running down. So, now, all you got to do is basically do the math and multiply this out and you'll generate equations. So, what can I do? I'm going to do it over here. I'll start you off. Why are you guys all late? Huh? Why are you guys all late? You slept in. You? You? Okay, get in. You're dead tomorrow, buddy. You're half dead. Okay, yes.
You know, you group them into like groups before.
Yeah, we're gonna group them that way off the top. We'll slide left to right. That way you'll just have it. Okay, so which is the order that I taught you guys to multiply in? Doesn't matter. Okay, so Joanna, A plus what do we have? We have A plus B plus 0 equals which entry?
1,
1, 1. A times 1 is A, plus B times 1 is B, plus C times 0 is 0. So far you have an A plus a B, right? Equals that entry.
That's number 1, 1.
Oh, entry 1, 1. I apologize. Absolutely right. Okay. Now why don't you guys go ahead and start building all of the equations. You did that one, right? Now why don't you go ahead and do, what did we say, Leora? We want to get all the ABCs, right? So why don't you now do this with this equals 0 for the second entry. I'll do that one, and then you guys, I'll do that one with Joanna, and then you guys will do the rest. So Joanna, what do we get? We get negative A plus 2B equal plus C.
Yeah. And so the only
It's hard from here. Negative A plus 2B plus C equals that entry, right?
Yeah. So 1.
Equals 0, right? Yeah, but yeah. Can you guys do the rest of the equations?
Yeah.
And then, yeah, go ahead. Do the rest of the equations yourselves. Go. While you do, I'll do too. You guys will correct me if I screwed up. That's a B and a C. The B and the C, where the hell are we? And after this, we'll take up the test.
Then we take
B and the C is going to give me a 0, I believe. And then I'm going to say, it should be the same thing as I'm going with the first column. So it just should be like that. D plus E, except instead of a 1, I think it's a 0. And then I think it's going to be minus D plus 2E plus F equals a 1. And then a D plus E equals a 0. Leora, can you double check those?
Yeah.
And then I basically, so D, E, F, G, H, I. So now I have a G plus H equals a 0. And then I have a minus G plus 2H plus I equals a 0. And then a G plus H equals a 1 now.
No, it's I plus H.
We see D, E, F.
You wrote G plus H twice in the top equation. G plus H equals 0, then G plus H equals 1.
So then I made a mistake here too. Yeah, because this is B plus C, so this should have been E plus F. This should have been E plus F, right? And then this should be H plus I, right? Those look right? Who's getting those equations? Is anybody getting those? 1, 2, 3. Corey, no? No idea? Yeah? Natalie? That's not a Natalie, that's a Natalie. Natalie? Yes? No? No, not I just, does it make any sense?
No, I don't get it.
Okay, you're not clear on what I'm doing. Okay, where does it all fall apart? Is this cool? Is this good?
Yeah.
Is this good?
Yeah.
Was this good?
Yeah. But then, like, the thing at the bottom, like, where did you get A, B, C, D, E, F, G, H,
Oh.
I from?
This is, so when you dealt with square 2x2 matrices, I would give you a formula. I would be like, here's the recipe by which you take the entries in the coding, the 2x2 matrix, and you create its inverse. But did I give you a formula for the inverse of a 3x3? No, I only gave you one for a 2x2, so you got to figure out what to do. So is it true that when you take the inverse matrix by the coding matrix, you should get back the identity? Like, do you agree with this reality?
Yeah.
But I don't know what the inverse matrix is, so I just label the entries, A through I. You could have called them X, Y, Z, whatever you want. It's like, I need to know that you buy into this being true. That this should be true. That if you multiply the inverse by C, you get back I. That was what we said by definition way back when. Now it's a matter of carrying out the multiplication and seeing what equations you get. Now, do you understand how I got those equations? Okay, so how do you get this entry here? You do this by this, plus this by this, plus this by this equals that. What's this by this? 1A, which is A. What's this by this? What's this by this? So you have an A plus B equals the first entry, which is? Right? Let's get the next entry. A by -1 is negative A plus equals that entry, which is? Right? And so on and so forth. You see?
How did you know what the identity matrix is?
Oh, no. The identity matrix. The identity matrix by definition. Why are you late? Okay. This is getting bad. Don't be late tomorrow. This is getting really bad. Yeah. What were you saying? How did I know? Oh, the identity matrix? Because that's by definition. Because the identity matrix is the inverse matrix. It's a definitional thing. An inverse matrix by definition exists such that when you multiply it by the other matrix, you get back the identity matrix. And what is the identity matrix? The identity matrix is the matrix that when multiplied by any other matrix gives you back that matrix. So I times M gives you back M. And what is a matrix that will do that? A matrix with 1s down the diagonal and 0s everywhere else. Remember I took you through that? I showed you that when you take a matrix like this and you multiply it by a matrix, you get back the original matrix. You're lost. A little less lost?
No, it's just confusing.
Is there anybody else who's really confused?
I got the equation, but I'm just confused about the dimensions of the inverse that you got.
Of the dimensions of the inverse. Or how I came up with 3 by 3?
Yeah.
Okay, we knew, what did we know? We knew that this was a 3 by 3, right?
Yeah.
If this thing is going to exist, this dimension and this inner dimension have to match. This is a 3, therefore this has to be a?
3.
Okay. Furthermore,
So you know that the inner dimensions have to be
3, which means you know the dimension here is 3 for the inverse. Now, when the inner dimensions match, the dimensions of the final matrix are the outer dimensions. Here's an outer dimension of 3, which means that the result of these two, of the multiplication of these two, gives you a 3 over there.
Why didn't they match?
No, they don't. If you multiply a 2 by 3 by 3 by 8,
Yeah.
these have to match, and the result is a 2 by 8.
Yeah.
So, these two match, so for this to work, if that's a 3, that must be a 3, and the results are going to be whatever you have here by a 3. So I know that this thing is going to have a 3 over here. So the question is, what is this? But the identity matrix is a square matrix, always a square matrix. So if I know that's 3, guess what that is?
3.
And if I know that's 3 and that came from here, guess what that has to be?
3. Okay.
Yeah? That makes sense?
Yeah.
Okay, so you get these groups of equations, right? Now, notice, I group them into separate groups of 3. Because of the nature of the multiplication, A, B, and C never, any of A, B, and C never touch variables, never relate to variables D, E, F, or G, H, I. Do you see that? A, B, and C always relate to each other, but they never relate to the other 6, right? And vice versa. So that means you have a system of equations here with 3 variables, 3 unknowns. 3 variables, 3 unknowns. Just like 3 variables, 3 unknowns. Just like in grade 9, like you have pennies, nickels, dimes. You have this many coins in the bowl. You have twice as many nickels as pennies, and blah blah blah. Solve for the number of nickels, pennies, and dimes. Right? It's the exact same thing. So you can solve for this by substitution and elimination. Yes? Does that make sense? Okay. What did I get? All right. What did I get? They're on the right side. Tell me. What did I get for A?
Okay, A equals 1/2.
Yeah. B.
B equals 1/2.
Yeah.
C
C.
equals negative 1/2.
Yeah. Here.
E
D.
equals 1/2.
D.
Yeah, F equals negative.
Oh, wait. D is a half. D is negative a half.
No, wait.
What did I get for D?
Negative 1/2.
Okay. What did I get for E?
1/2.
Yeah.
F is negative 1/2.
Yeah.
H is negative 1/2.
G.
No, I know, but like I'm following the. Okay, G equals 1/2.
H.
Negative 1/2.
Yeah.
I equals 3/2.
Okay. So what that does is that tells you what this is, right? Okay? That means that C inverse is, what is A? 1 over 2, 1 over 2, minus 1 over 2, where is D? D is minus 1 over 2, what is E? 1 over 2, F, minus 1 over 2, G, 1 over 2, H, minus 1 over 2, I, 3 over 2. If this thing worked, I should be able to take that matrix and multiply it by the coded result. Cross our fingers. You guys are going to do the arithmetic, not me. And hopefully we get back the original message. If not, it's Arish's fault. And, isn't that what Steve Jobs taught you? Blame somebody else. I'm just joking.
Too soon, sir. Too soon.
Please, God, let that give you back help me. I don't know if it does. Anyhow, well, I'm gonna let Kim do that. Here's the last thing I want to show you. By the way, did you guys follow what I'm doing? Okay, Sam follows. Some of you follow. Here's what I want to show you. Which is interesting. Take a look at these. This is the most interesting thing. And for those of you, how many of you are taking calc and vectors next semester? Okay, so you're gonna learn something. You see how this is an A and a B? You guys are familiar with x's and y's. Imagine that that was x plus y equals 1 minus x plus 2y plus z equals 0 and y plus z equals 0. And this is why I want to attach this to the last one if we can, when we, you know what I mean? We can attach this to the last time we filmed, when we stopped filming last time. Yes. Not right now, but later.
Yes.
Whatever,
Sir.
when you do your thing. Don't worry, I got some good lunch coming up for you.
Oh, swag.
Take a look. These two. Okay, take a look at this equation right here. You see this equation? It's got 3 variables: x, y, and z. Right? You see that? You guys remember standard form for linear equations? Ax plus by plus c equals 0. Do you remember that from grade 9? That's the form of a linear equation, right? Which is in 2-dimensional space, like that, right? When you go ax plus by plus cz plus d equals 0, which is what this is, it's like minus 1x plus 2y plus 1z plus d, the d is 0 in this case, equals 0. That is the equation of a plane. And no, I'm not going to take you to the proof now. That'll happen in the second half of calc. What is a plane? A plane is a flat region of 2-dimensional space. Okay, that's a plane, a piece of paper, right? Now it extends in that direction, and that direction, and that direction, and that direction forever. Don't tell me it didn't work.
I got the first column, 8, 12, 13, but I didn't get the second one.
Okay, we'll have to go back and look at it. Maybe we made a mistake
So
somewhere.
it's okay. I'll check to see what the inverse of C.
Yeah, take a look carefully. So you're saying the HLM worked,
Yeah.
but the EPE didn't work? Okay, so you're gonna do some work while I talk. Okay, so
Do you want to look
Yeah.
at that?
what? Remember yesterday? The reason why we said it didn't work for the dimensions of the matrix yesterday is because you were in 2D space and you had 2 equations which intersected at the origin because they had no y-intercept, and then you had one that had a y-intercept. So how could three linear equations on a flat surface all intersect at the same place if 2 are intersecting at the origin and 1 is not? You remember that? That's why it didn't work. And now you're not dealing with lines in 2-dimensional space. You're dealing with 2-dimensional surfaces. Each one of these represents a 2-dimensional surface. So then the question is, how can that correspond to a solution whereby you end up with one unique place in space? So I want you to imagine that this equation, a plus b equals, here, write down a plus b equals 1 on that one, and write down minus a plus 2b plus c on that one. You write it bigger on the next, here, you can write it bigger on this one, and then write down the last equation on that one. So this piece of paper, yes, it extends this way, this way, this way, and this way. It represents that equation, okay? You follow? Now, I haven't taken you through that proof. You'll learn that next year, next semester, second half in calc and vectors. This piece of paper is going to represent that equation, okay? And this piece of paper is going to represent that equation. Now, I cut them up a little bit. You probably know. Who thinks they know why I cut them the way I cut them? Okay, you want to give me a hand here? Let's see if we can do it. So you're going to hold one equation. and I'm going to hold, and Cruzy, you're going to hold that equation. Okay, we'll try and get this on camera. Here, let's stand up. Let's do it over here so they can actually see.
Sir, are we allowed to have the kids on video?
Are you allowed to what?
Have the kids on video?
Oh yeah, right. Are your parents cool with this? Are you cool with this?
Just like if it works, like type before and there's an 11.
Okay, hold that.
We'll do it Tom and Jerry style. You can't see their face. Just their hands.
Now what we gotta do is, I gotta go this way.
You don't see the guy face either. The mom and dad or whatever. No. Gotta watch your Tom and Jerry again. Swagger. Swagger.
I don't know. This goes like this. Yeah, and then this is gonna go like through there. There. And then okay, so we're gonna go like that, and then you're gonna start that Don't bend my paper. Okay, I'll do it myself. Alright, pause the thing for a second. It kind of sucks because like they're supposed to be flat, right? But do you see the idea here?
Yeah.
Now, come on! There, that's pretty good. There's one place where they're all existing, right? They're all existing right there, right? At one point. And that one point in space for this group of actual equations, remember, because these three planes only would correspond to this first cluster of equations. You with me? Corresponds to, let's say, an x value of a half, a y value of a half, and a c value of -1/2. If you want to think about it in terms of space, meaning if you imagine positive x going that way, y going up and z coming at you, that means take one step this way, right? Take one step up and it's negative a half. It's not one step. Take a half step this way, take a half step up, and a half step into the blackboard, and that corresponds to this point. And that particular point corresponds to the solution of A, B, and C, the first row of the inverse matrix. And that's why it works in this case, right? That's why you can have the 1, 0, 0 entry and still have them all come together. That's why we couldn't before, because you were dealing with linear equations, 2 of which went through the origin, 1 of which didn't. They never intersected. Now you're dealing with 3 planes. And those 3 planes can coexist in one particular spot. Does anybody know what the hell I'm talking about? Show of hands of those who kind of understand what I mean. Tim, how can you not understand what I
I
mean?
don't know calculus, I understand everything else.
This isn't really calculus, this is
Okay.
just vector. It's a visual thing. Anyways, did you double check it? Did it work?
Yeah, it's because I've read your -11 is a -4.
So it works. So it works.
Do you want to do a celebration dance? Oh, wait. Yes, do it again.
That's all you're getting. That's all you're getting. All right. Now you guys want to argue about your marks, right? Okay. Let the games. Yeah, I don't think you guys really want to.
Unless, does this serve values?